Good morning to everyone. So today's lead code question is 3640, that is Trionic Array Part 2. So basically in this question we are given an integer array nums whose length is n, and we have to basically what is a Trionic subarray. So basically it is a continuous subarray where let's say from index L to R such that 0 is less than equal to L and R is less than N, and for which there exist two indexes P and Q such that L is less than equal to P, less than Q, less than R, and the condition is that uh, nums of L to P it should be strictly increasing, P to Q strictly decreasing, and Q to R strictly increasing. So basically a trionic subarray is an subarray whose elements should be like this: first strictly increasing, then strictly decreasing, and strictly increasing. They should not be constant, they should be strictly increasing, decreasing, and again strict increasing. And at the end we have to return the maximum sum of any trionic subarray in this biggest in nums, right? So if we'll see the examples, so we are given 0, so let's draw it: 0, -2, -1, then -3. Wait, I get it wrong, I think. Yeah, 0, -2, then wait. So from 0 to -2 it will decrease, then increase, then again decrease, increase, then again increase, and then decrease. So basically it is somewhat like this. So what was our condition? First we take increasing part, then decreasing part, and then again increasing part. This is what we require, right? So if you'll see this is decreasing, so we want to be considering this part, right? So see here it is increasing, so increasing, decreasing, and then again increasing. So basically it is up to this part, right? But what we need to do is we have to maximize the sum, right? So if you'll see the sum, so it is -2 to -1, sum is -3. Then if you'll add this -6, -6 plus 0, -6, and then 2, so the sum is -4, right? Then if we consider this increasing and then decreasing, there is no again increasing part, so there is only one trionic subarray and whose sum is -4. Now let's see this one. So 1 to 4, 4 to 2, and then 2 to 7, only one trionic subarray, so we'll be taking sum of that, that will be 14. So if you'll see the constraints, the constraints are like the nums length can be up to 10 ki power 5. So what does this says? That the possible approaches can be either of either in big of n or n log n, n or n log n, or big of n. These two possible approaches can be these two can be the time complexity of our possible approaches, and our nums of I can be between -10 ki power 9 to 10 ki power 9, means negative elements are also possible, and also it is guaranteed that at least one trionic subarray is existing, right? So if we'll discuss the approach, so what we need is we need a subarray which is first increasing, then decreasing, and again increasing, and we have to return the sum of that subarray. So what we see, our first part is increasing, second part is decreasing, and third part is again increasing. So if we have to maximize the sum, and we have to maximize the sum, so if you'll see the sum of the decreasing part is always considered, no matter it is positive or negative, it is always taken into consideration. Like this decreasing part, we will always be considering the sum of those elements. So now if we'll see, earlier we have increasing part, decreasing part, and again increasing part, but this will be considered every time. So now to maximize the sum, we have to maximize the sum of the increasing parts, right? First increasing and second increasing part. So what are the cases for possible cases for first increasing part? So for first increasing part, either the overall sum of elements can be negative. So let's take an example. So suppose this is our first increasing part, -3, -2, -1. Then the overall sum is negative. Then what we'll be taking? So we'll be taking the closest element, right? Instead of taking the overall sum, because it will reduce the sum. So we'll be taking this element directly. What other case can be? The sum is either positive or 0. So in that case, we will be considering the whole sum, right? Now, if you'll see, if the overall sum is positive and first element is also positive, see 2 is positive, so we'll be taking the overall sum. What can be the other case? Like initially some elements are negative, then positive, but overall sum is positive. So instead of considering these two, if we'll consider only these two, then our sum will be 5. So we should consider these only. And then case for second increasing part, like uh, this this second increasing part. So if overall sum of elements is negative, then we will be taking this first element only. Instead of taking the sum of all these three elements, we will be taking this only, because it is -7. But if we accumulate this, then it will be -18, which will be reducing as the overall sum. And if overall sum is either 0 or positive, right? If it is 0 or positive, then what does that means? Like initially some negative elements are there and then positive elements, then we have to take the overall sum, right? So if you have seen, basically we have having three parts, or we can say three subarrays. So finding the sum every time by iterating will be time consuming, right? So what we can do is we can use prefix sum. By prefix sum we'll be storing the sum of all the elements from index 0 to index I at prefix of I. So we do whenever we need uh, sum of any range, we'll be using this prefix array, right? And one more thing is that here we have to denote three. What are the possible choices we can say in the array? So either our subarray is strictly increasing, so we'll be denoting that by 1, or it can be strictly decreasing, so we'll be denoting that by -1, or it can be constant, so that will be denoting by we'll be denoting by 0. Now what we need first increasing, then decreasing, and then again increasing. Or in other case, what we can say, we need 1, -1, and 1 using the above denotion. And now suppose we have our trionic subarrays from L to R, where our middle indexes are P and Q. So what will be the sum of this trionic subarray? So that sum of this trionic subarray is prefix of R plus 1, means sum of elements up to index R plus 1 minus sum of index up to this prefix of L. So let's see. Suppose we are having a subarray this, and we want to find the sum of this range. So what we will do is we will take this sum, that is the sum of these previous elements, and then subtract this sum from uh, the sum up to this element. If we'll subtract from this, if we'll subtract from this sum to this sum, we will be getting this sum, right? And as you know, we have to maximize our sum. That means what we can do, we can minimize this prefix of L, right? And what other thing when we can do is we can maximize this prefix of R plus 1, right? Like this 2 points are important, you should keep those in mind. We'll be using those letters. And next thing is like from where our subarray should start. So as we need increasing, decreasing, and increasing, so we will be starting once we get the increasing part, right? And then we should get find decreasing and then again increasing part. Suppose initially we have constant, or initially we have decreasing part, that those cases we will be skipping, we will be taking from increasing part, right? So let's see the steps. So first of all we will check whether at our current index we have a increasing subarray start, right? What can be the possible cases? Either it is constant or decreasing, so we have to skip those cases. If at the start or at our current index we don't have increasing subarray, then we'll be skipping those indexes in the start of the array, like I am talking about the start of the array, right? And check at next until we do not get a increasing part, right? Suppose if we get an increasing part, then what is our aim? Our aim is to minimize the prefix of L, right? As above we have seen, our sum is prefix of r plus 1 minus prefix of L. So to maximize sum, we have to minimize prefix of L. So we, our aim is to minimize this prefix of L. So let's take an example to understand this thing. Suppose we have minus 7, minus 6, minus 5, 4, 5 and 3. That is this way and this, right? This is the subarray. So to which elements should we consider in this part to maximize the sum? So like this is the increasing subarray part. So which element should we consider? Should we consider the total sum? If you'll see the total sum, the total sum will be minus 9, right? So if we consider this part, then our sum will be 9. So how we will find that which part should we consider in the increasing first increasing subarray? So for that we have to minimize the prefix of L. So if you'll see the prefix array, so here our prefix of L is minus 7, then minus 13, then minus 18. So up to now this is the minimum. Then minus 14, which is greater than our minimum, minus 8 greater, minus 5 greater. So if we'll see which one should we take, we should we should take this sum, that is minus 18. That is, we should not consider these elements, we have to minus these elements from our sum. Our sum was prefix of r plus 1 minus prefix of L. So if we'll reduce this sum from our prefix of r plus 1, then our sum will be maximum, right? I hope you are getting it. And then what we'll do is we keep moving our index ahead until we get our strictly increasing subarray, right? And now once we get our, suppose we started from here and up to index this, we get our increasing subarray, right? Now if we can consider this as peak, this is the peak of the increasing subarray. So we'll be storing this index, we'll be storing the index of the peak, and with that also we'll be storing the minimum of prefix of L, because that we have to subtract, right? Subtract. Now what next we want? So we get the increasing subarray. Now we want the decreasing subarray. So we want decreasing subarray, but what can be the other possibilities? The other possibilities can be either our array is finished, like all the elements are finished, there are no other element left, right? So we won't be finding any decreasing and increasing subarray because our array elements are finished. What one more possibility can be, suppose it in increasing then constant, so this case also won't be considered. So these are the two possibilities. So before checking the decreasing part, we should check whether these two cases are not there, right? So we will be checking the above two conditions, and if none of the above two conditions are possible, then we iterate over the decreasing part and keep updating our index until we keep getting decreasing subarray. And as we have already seen, in the decreasing part, no matter whatever the sum of these elements, we have to consider those, right? So we'll be taking these sum. So now up to this step, what we get? We get the starting index of the increasing subarray, peak index, and the index of the valley, that is the final index of the decreasing subarray, right? And now after this step, what we want again, we get increasing, decreasing. Now what we want, increasing subarray, right? We again want increasing subarray, but what are the possibilities again? Again the possibility is that our array is finished, that we can't get any increasing subarray part. So array can be finished and we can't get a increasing subarray. What other case can be there? We get increasing, decreasing, and then we get constant. So this case should not be considered, because in the question it was mentioned that those should be strictly increasing or strictly decreasing. So again we have to check for these two conditions, right? Again, suppose if these two conditions are found, then we again start from the finding increasing subarray, and then decreasing, and then increasing. But suppose if those conditions are not found, then what is our, then we'll be finding for second increasing part. Already we have get the first increasing part and decreasing part, now we want the second increasing part. And as I have told you, our sum will be prefix of r plus 1 minus prefix of l. This is L and this is R, right? So our sum will be that. And earlier we have minimized prefix of L. Now what we do is, if we can also maximize prefix of R plus 1, right? And as I already mentioned, the last index of decreasing subarray is valley. We named that as valley. So prefix, so for having increasing subarray, R, this index R should be greater than or equal to valley plus 1. At least one element should be there, right? This is valley, right? So R should be greater than or equal to valley plus 1. So what we have to do is, we have to maximize prefix of valley plus 2. If we'll put R is equal to valley plus 1, then it will be valley plus 2. So we have to maximize this and say our current index is I. Let's say our current index is I, and then R can be greater than or equal to I plus 1. So what we need to maximize, prefix of I plus 2, that we need to maximize the this sum, right? So what we do is, we keep updating our index and checking if it is increasing, then we find prefix of pref r, that is maximum of prefix of I plus 2. I have already explained you how we get I plus 2, right? So now what we get, now we get maximum prefix of r and minimum prefix sum of l. So if we'll subtract these two, then we'll get the answer for this are current Trionic subarray. Let's me tell you, suppose this is our array and this is our Trionic subarray. So if we'll find minimum prefix of l, right, minimum prefix of l and maximum prefix of r, these two sums starting from here, and if we'll subtract that, then we get this answer, right? So let's see the code part. So we have initially stored the prefix sums in a prefix array, and then this is a function which will be denoting the sign, like for increasing 1, for decreasing part it will be given -1, or for constant part it will be giving 0. So we will be passing the difference of two numbers here. So if that difference is greater than 0, then it will be returning 1. If the difference is less than 0, it will be returning -1, and else it will be, if the both numbers are same, it will be returning 0, right? And then we have made a variable which will be storing our answer, and then from integer I is equal to 0. So we are starting from I is equal to 0. Now, as I already told you, our first part should be an increasing part, then decreasing, and then again increasing. So we will be checking the sign by passing the difference to that function. So if the sign is not equal to 1, means it is not increasing. For increasing 1, for decreasing -1, and for constant it is 0. So if the sign is not for increasing part, then we will increase the index and again continue means again we will be moving to the start of the while loop, right? So now suppose at some point we get the start of the increasing part, so we'll be storing that index, and then what we want minimum prefix of l, right? So we made a variable to store that. Now we have used a while loop. In that we'll be updating our index until it is do not reach to the end of the array, and the difference of the numbers is not equal to 1, means they are not increasing. So we'll be checking minimum of prefix all comma prefix of I to find that number from where we have to start. So already I've told you using an example. Suppose -5, -4, 3 and 5. So instead of taking from here, it will be good for us to take the increasing part from this part, and this will be finding using this minus minimum prefix of L. And if we'll subtract this part, then we get our maximum sum, right? And once this condition is failed, that means our increasing part is done. So we'll be storing peak is equal to this index, so we get our peak, right? Next what we do is we'll check whether our array is not finished or constant is not there. This is for constant, right? Means earlier increasing was there. Now if it is not equal to 1 -1, means it is, if it is not decreasing, then that means it is constant. So if we get constant, then what we have to do is we have to again find for the increasing part. So what we'll do is we'll again move to the start of the loop, right? But suppose none of the condition has satisfied, then we have to find for decreasing part, right? So for decreasing part, we'll be again using a loop until we reach to the last of the element, and then checking the sign whether it is not equal to -1, then we keep incrementing our index. Suppose once we get the last element that we are storing into valley, so it was peak, this index is valley, right? Now we get our increasing part, decreasing part. Now we want increasing part, but what if the array has finished, or what is constant is there? So for checking that this condition is there, means if I is equal to greater than equal to n-1, means array has finished or not, or the sign is not equal to 1. Not equal to means 1. Earlier it was decreasing, means sign was -1. So there are no chance that from this point sign was can be -1. So sign can be either 0 or sign can be 1. So if it is not equal to 1, then that means it is 0, means constant elements are there. So we won't be considering those cases like increasing, decreasing and constant, then those can't be considered. So what we'll do is again move to the start of the loop, right? Next thing is, like, we get increasing part, we get decreasing part. Now what we want, increasing part, and in this what we want, maximum sum, like maximum point, that point up to which the sum is maximum in the increasing part. So we stored a max prefer array, and then we will be iterating up to the last of the array, and until we get our increasing part, means our sign is 1. So we'll be checking that prefix of I plus 2 is maximum than the current prefix max prefer or not. If it is there, then we store it. So how can we explain this, understand this? So let's take an example, -2 1 0 4. So up to this part prefix is -2, up then -1, then -1, but up to here prefix is 3. So it will be good for us to take up to that point for which our prefix is maximum. So that's why we are checking this. And then suppose at some point our increasing part has been satisfied, means either we get some decreasing or some constant. So at that point we get our final index. So our what will be our answer? So our answer will be either maximum of the previous answer or maximum of the max max prefer that we have stored here, like the prefix of I plus 2, or the prefix minimum prefix of the left part. This is maximum prefix of the right part minus maximum prefix of the left part. That will be the answer of our current trionic subarray. So this way we'll get an answer. And suppose our array is like this, right? So this is valley part, and this is no sorry, this is peak part, and this is valley part. So we have already checked this part. So there is a chance that this part is used in the next trionic subarray. So we'll be starting from this part only in the next iteration, and at the end we'll be returning our answer. Thank you. I hope I am able to explain you properly. So if you liked the video, please make sure to share and subscribe the channel. Thank you.